20 degrees. It's one angle. Okay? The only thing is that we don't know what the value of theta is, because that's the one we want to calculate. So you don't touch any part of this. Okay? And be aware that this is one angle. Okay? So you divide both sides by 3. So when you do that, you get 0.425 over 3. Then you'll be left with cos theta minus 20 degrees equal to. Now, for now, don't try to simplify this using a calculator. By now, you should know that you can put this in the calculator. So for now, I'm going to write as it is 0.425 over 3. Then you need to make sure that you remove the cos on the left-hand side. Don't touch the theta and the 20 degrees. They are inside brackets, they are one term. So you take the cos to the right, you end up getting theta minus 20 degrees is equal to shift cos of 0.425 over 3, like that. Now, as I told you in the previous lesson, that you can put this in the calculator. So you take out your calculator, as I told you. Now, it's very important for you to make sure that you don't round off too quickly, because we need, whatever angle we are going to get there, we need the whole angle with all the decimal places. So if you press equals, it gives you that. Okay? Now, that answer, we need it as it is. We won't round it off. Okay? So I'm going to write it here as 81.85 dot dot. Okay? So it becomes theta minus 20 degrees is equal to 85.5. It's 81.85. So that's 81.85 dot dot. Now, the reason why I'm doing this is because I need all the digits. Okay? So I'm not going to round off anything here. Then I'll take the minus 20 degrees to the right. When I do that, I'll get theta equal to this 20 degrees plus that 81.85 with all the decimal places. Now, you'll find that your final answer, which we can round off, is going to be 101.86, because this 81.85, the third digit after the comma is a 5, so we are going to add 1 to this first 5. So you end up getting 81.86 plus 20, which will give you 101.86. So our theta is going to be 101.86 degrees. Okay, so this is one example where you have brackets. Okay, you have got angles inside the brackets. Now, there are times when you can also have brackets, then a constant outside the bracket. So I'm going to do that as the next example. Okay, there are different types of trigonometric equations. So you need to be familiar with the different types. Yes.
So for trigonometry, so I'm just dealing with the right angle triangle or with the triangle.
Generally, it's the right angle triangle. In grade 10, it's the right angle triangle. Yeah. In this grade, it's the right angle triangle. Yes.
So when we get our final answer, it's not going to decimal places.
Yes. Okay. In most cases, you are supposed to fit. If it's not specified, round off to two decimal places. If it's specified based on the question, then you round off based on the instructions given for that question. Okay, but generally to 2 decimal places. Okay? Any other question? Okay, if you don't have any question, then I need to move on. But I want you to be aware that this angle, it has got a brother or a sister which is in the third quadrant. But because you are in grade 10, we don't want to get into the details now of all the possible solutions. Okay? We don't get into the details of all the possible solutions. So we just stop there. But you need to be aware that this angle is in the second quadrant. It has got a corresponding angle which gives you the same ratio, and that angle is in the third quadrant. Okay, but that's not for grade 10 now. Right, the next example. Right, let's bring in a constant now, together with brackets. Oh, by the way, I said I want to show you a second method for this. Am I right?
No.
Yes, I said so. Okay, let me show you a second method before I forget. So we have got 3 cos theta minus 20 degrees is equal to 0.425. Right, this is method 2. Okay, this is method 2. The previous example, this was method 1. Okay, I almost forgot that. There are 2 ways of doing that same question. So the second method, we can introduce a substitution, right? Whereby we can say let a specific letter, which is not theta, any other letter, we can use the English letters, like say y or x, be equal to theta minus 20 degrees. Okay? Then we can work in terms of x, then later bring in the theta. Okay? Don't worry, it's not that complicated. This is allowed. So we say, let's use x. Let x be equal to theta minus 20 degrees. Okay? Because majority of you will have issues with that theta minus 20 degrees. I have seen a lot of things being written over the years. So sometimes it's the best way to bring in one variable, okay, or a monomial. Remember, you did algebra, binomials, trinomials, monomials. So we can introduce a monomial and you can call it what? X. Because this is a binomial. Theta minus 20 is a binomial. Okay? When I do that, this equation becomes 3 cos x equal to 0.425. Okay? But our original trig equation is in terms of theta. Okay? So we'll solve for x first, then go back to theta. Okay? So this becomes 3 cos x over 3 equal to 0.425 over 3. You get cos x equal to 0.425 over 3. Then we isolate. The good thing is you are familiar with this. Okay? You are familiar with a trig equation like that, where you have got a monomial here, not a binomial. Okay? Then you take the cos to the right, it becomes shift cos of this fraction, 0.425 over 3. Fortunately, we know what this shift cos is equal to. So your x becomes this value here, 81.85 dot dot. So you end up having 85, so it's 81. It's 81.85 with all those digits. Okay? Now this is x. But what are we trying to find? Theta. So we go back to the substitution. Where there is x, we put this. Okay? Then we solve for theta. So I can rewrite that by saying theta minus 20 degrees is equal to x. Remember, if x is equal to theta minus 20, we can also write it as theta minus 20 is equal to x. And then where there is x there, we put the 81.85 with all the decimal places. You'll find that we'll get to the same point where we get theta equal to 101.86 degrees. Okay? So this is another method if you like it. Okay, if you don't like it, it's fine. But you can also do it this way. You can introduce a second variable, then go back to the original variable. Okay? Yes?
So I'm confused. You see, you know, let x equals theta minus 20 degrees.
Yeah.
Then in the second after that, so where does theta go to? So because I don't see it in the second question.
So it says let x represent theta minus 20.
Oh.
So you take that away and you put x there. And then when you're ready, you substitute it back in.
Thank you.
I don't care this at all.
Okay, okay. If you don't like that method, then we use the first one. Okay. If you understood the second method, okay,
First one is
listen. If you understood the second method, you can use it. If you don't like it, then you have only one option using the what? First method. Okay? But the concept of substitution is a very common method in maths. Okay, sometimes you can introduce a third unknown letter, okay, or a second unknown letter. There is nothing wrong with that. But it helps to simplify the equation in this case. Alright, let's move on. Any other question? So if you don't have a question, then let me carry on. Right, another example, I'm going to introduce a bracket plus a constant outside. Okay, so we can have 2 tan, let's call this one here 2 theta plus 10 degrees. Then we are going to have a constant, okay, a constant like say -1. Maybe this will be 0.5, like that. Okay, we want to solve for theta. Okay, now to solve for theta here, you have to be very careful. First thing, we need to know that this -1, it can be taken to the right hand side. Then you need to make the coefficient of tan 2 theta plus 10 degrees equal to 1 by dividing both sides by 2. So the first step here, it will be to take the -1 to the right. If you do that, you get 2 tan 2 theta plus 10 degrees is equal to 0.5 plus 1, you get 1.5. Okay? Please, I hope you can see what I'm doing. I'm not touching the binomial inside brackets. It's one angle. You treat that as one term. If there's a term outside, you are allowed to take it to the right hand side. As long as there is a term which is not inside brackets, you can take it to the right hand side. Okay? Then we divide both sides by 2. Please, when you divide both sides by 2 here, this 2 is divided by that 2. The 2 does not divide this 2 theta and the 10. Please, because the tan 2 theta plus 10 is one thing. It's one term. Okay? So this becomes tan 2 theta plus 10 degrees is equal to 1.5 over 2. Now this is the same as 3 over 4. You can convert it to a fraction if you want. It's the same as 3 over 4, but I'm going to work with it as it is. Then from here now, I have to eliminate the tan on the left. Take to the right hand side, it becomes shift tan or arc tan. So we end up having 2 theta plus 10 degrees is equal to arc tan of 1.5 over 2. Okay? Then use your calculator there. So I'll bring my calculator. So my calculator there, I'll clear that. So it will be shift tan, put the fraction option. Okay, I hope you are learning how to work with the fraction option without rounding off quickly. So we put the fraction option 1.5 divided by 2. Okay, and then you get 36.86. Now for now, I'm going to write this 36.86 with dots. So that will be 2 theta. So this will be 2 theta plus 10 degrees is equal to 36.86. So that's 36.86 with all my dots there. The objective is to get theta. Okay? Then I'll check this 10 to the left. You get 2 theta is equal to 26.86 with all those decimals. Okay? Then I'll divide now both sides by 2. So you get theta equal to. Now, fortunately, because I didn't round up too quickly, if I go back to my calculator, all I have to do is divide. Be very careful. You have to subtract 10 from that. Then you divide by 2. So I'll subtract 10 from it. Okay? Whatever answer I get, then I can divide that by 2. And then you get 13,43 to 2 decimal places. Okay? So it will be 13,43 degrees. Okay? The theta is an angle. Okay? The theta is an angle. So if you take this theta, 13,43, if you put it here, you use your calculator, you must get that. Let's try it, just as a try on there. Okay, just to check. Right, so the next thing that I'm going to do is to put that 13,43. I'm just going to do this to show you that you can check if your answer is correct. So I'll put everything there. 2, then tan. This is 2 times theta, so it will be 2 times 13,43. Okay, are you looking? You must also be doing it. Right, so I put my open bracket there, then I multiply that plus 10, then I'm going to close the bracket. Okay, fortunately your calculator has got a screen which can extend, so it can accommodate all that. Then you subtract 1 from that. Okay, then you press equals. Okay, the answer that you are getting there is 0.4954, so on, right? If you look at the third digit, it's a 9. The second one, it's a 9. So if you round off to 1 decimal place, you end up getting 0.5. And remember, the theta is rounded off to 2 decimal places, so that answer is correct. All right? So this answer here, it will be correct. Okay? But I'm going to remind you, if I give you a right-angled triangle like that, okay? I hope you are aware that if this angle is 20 degrees, it means that angle will be 90 minus 20, which is what? 70. I told you about this. So what this statement means is that if you add alpha and beta, you will get 90. Okay? Which means if you have a right angle triangle, the third angle is going to be 90 degrees. So alpha is acute, beta is acute. Please, alpha and beta are sizes of angles, but they are unknown sizes. Okay? So your beta is between 0 and 90. Alpha plus beta is equal to 90. And alpha is also between 0 and 90. So both alpha and beta are acute. So you're asked to calculate cot alpha. Okay? So if you understood the concept of trig ratios based on a right angle triangle, then you shouldn't have any issues with doing that question. So to carry on, we need to determine beta first using trig equations. Then we subtracted beta from 90 degrees to get alpha, because all trig ratios are based on a right angle triangle. Okay? All trig ratios are based on a right angle triangle. So here, we start by writing 5 cos beta minus 3 is equal to 0. Right? I'm going to tell you something very important that I didn't tell you, but I'm realizing now that it's important for this question. So you take the minus 3, because it's not inside brackets, you take it to the right. So you end up getting 5 cos beta is equal to 3. Okay? Then we isolate the cos beta by dividing both sides by 5. So the next step will be 5 cos beta over 5 is equal to 3 over 5. So that will give you cos beta equal to 3 over 5. What's the objective? To determine the value of cot alpha, which means we need to know what is the value or size of alpha. But to get there, we have to get beta first. and use our knowledge of a right angled triangle. So from here we get beta equal to arc cos of 3 over 5. Then we go to our calculator, you press shift, then cos, fraction option, is 3 over 5, okay? And then you get your answer. Okay, that answer is the value of beta. Okay, now I suggest that you should not round it off. So beta is going to be 53,13. So beta is going to be 53,13 dot dot. Okay, so alpha, because here the equation says alpha plus beta will give you 90. Okay, alpha plus beta will give you 90. So what that means is alpha plus my beta, which is 53,13, must give me 90 degrees. Therefore, alpha will be equal to 90 minus beta. Beta is 53,13 with all the decimal places. Okay? Then alpha will be equal to, right? Fortunately, please don't do what I'm about to do now. If I want to get the value of alpha, it's a positive angle. Right? I don't want to reset this. So I can just subtract 90 degrees from that. Okay? Please don't do this. Okay? My answer is negative, but alpha is what? Positive. So it will be 36,87. Okay? 36,87. So that's 36,87 degrees. You saw what I did?
Please do it again, sir.
Yeah, okay. I didn't want to clear everything and start afresh. Yeah. See, when you're using a calculator, you have to be smart when you're using a calculator. Okay? So that's 36,87. That's the value of alpha. This is not the answer. We want cot alpha. Okay? Now, fortunately, we know that cot alpha is going to be equal to 1 over tan alpha. Okay? From our knowledge of reciprocals. So, what are we trying to find? It is cot of 36,887. So here we will say that becomes, so therefore, cot alpha is going to be 1 over tan 36,87. Okay, so I'm going to go back to my calculator. That is 1 over tan 36,87. So I'll clear that, bring in my fraction option, that's 1, then tan 36,87. Okay, then I'll close my bracket. So my answer is going to be 1,33. Okay, so my final answer, let me use a different color here, is going to be 1,33. Two decimal places. Okay, and then you are done. I want you to be aware that here you can put the value of alpha 36,7 is the way that I just wrote it. Okay. Any